in the room, what have we got? Have we got, are you all techie? Are you all engineering? Anyone not? Okay, people making what's architecture, like CTO architecture lead?
I'm with Grace Note, so...
Oh, okay, all right.
Metadata provider.
Perfect, and yourself?
Working with a client, digital asset management.
Okay, okay, cool. But the rest of you guys are all engineers, yeah, so we can go binary. Okay, so just word of introduction. My name's Don Robinson. I've been writing for streaming media since 2002. I've got a strong background in CDN and so on, but up till ran a CDN in the UK from 2001 to 2009. Realised that IP multicast is a difficult game, and I'm talking more about that tomorrow. So if you're interested in IP multicast, come and see that session after lunch tomorrow. And decided that it was better to sell picks and shovels to the gold diggers, and so I moved into software and teamed up with some guys who'd been building online fintech platforms, banking, retail platforms for a decade or so, very virtualized, and we built a microservices stack, which we widely deploy for live premium services. So we deliver, I don't know, north of 100,000 live events for clients like DAZN, NASDAQ, 70% of the world's financial news, and so on. So that's my own experience and where I first discovered in 2009, 2010, where I first discovered microservices. We're a little bit unusual and possibly doing something slightly different from these guys because we write in a funny language called Erlang, which has been a microservices SOA architecture for 35 years. So that might be a little bit off key. I'm sure words like Docker and Kubernetes are going to come up and containers are going to come up in the session. But what I'd like to do first of all is just scan along the panel, ask each of the panelists to just give us a brief introduction to what their focus is, what their background is, and so on and so forth, and then we'll get stuck into the panel. So, Nermeen, if I could start with you.
Hi, guys. So my name is Nermeen. I am with Cisco Systems. My background is really in embedded systems. I spent most of my career building collaboration endpoints from the IP phones all the way to immersive telepresence systems. In 2014, I discovered the world of cloud and microservices, and I haven't looked back since then. So I moved into the service provider video systems. So it's in Cisco to build a cloud-based video service. And I happened to just attend a meetup around Spring Cloud and discovered all the possibilities around distributed systems and microservices, and that's how we built our first cloud service, which doesn't exist today, but that was in 2014. And ever since, I have been very much involved in this area. Was from the very first adapters of Kubernetes when they came out, and containers. And here I am, back in collaboration, but working again in the area of microservices and cloud.
Perfect.
Hello, my name is Tanu Aggarwal. I'm Director of Engineering at the video platform on Twitch. I was hoping to see a lot more people here, but in the audience that we have here, how many people have heard of Twitch? Show of hands. Oh, wow. I'm super impressed.
Unanimous.
Unanimous, almost. But in any case, if you don't know about Twitch, what really is Twitch? Twitch is a community where broadcasters and viewers come together. Broadcasters are live streaming their passions, their interests, whether it be video gaming, whether it be gaming, or art, food, culture, travel. And then there's a community of viewers who will come together, watch this live streaming, and interact with the broadcaster or the creator. What this ends up doing is changing the way this entertainment is coming forth, or this viewer experience is coming forth. Now, most of us in the room are used to consuming video in a very singular fashion, or in a one-way fashion. A creator creates content for us, and we either consume it through OTT, or linear TV, or video on demand. The younger generation, on the other hand, is actually personalizing their viewer experience. Let's take the example of a person live streaming on Twitch. They're playing a video game. You will see them playing the game. You'll see an inset of them with their face, keeping on a banter with their viewers. The viewers, in turn, will now start interacting with them on the chat, on the polls, cheering them on. And this causes the person who is streaming to change how they're streaming. So the content here is interactively getting changed as it is being produced and live broadcast. I wanted to give you an idea what Twitch is, and to give you an idea of the scale of video that Twitch handles. On an average, we have 1.3 million viewers at any time, hundreds and thousands of live channels, 3 million unique creators that create every month on Twitch. And this results in the video team having to serve something to the order of more than 500 billion minutes of video last year. So that's quite a scale. How do we do that at Twitch? We run our own distributed global infrastructure that consists of ingest nodes as well as delivery nodes. And then over this network, highly connected network that we run ourselves, we actually run our video software, which is a distributed architecture. The reason I painted this picture for you, because when we talk about microservices, I want you to realize that this is a low latency end-to-end video streaming service, which is built on a distributed platform using distributed software components. And we're still able to keep the latency down to under 5 seconds so that that interactivity still stays. So I'm looking forward to discussing my microservice experience with you, which I've had a lot at Twitch and earlier in my career as well.
Perfect. Thank you, Tanu. Nathan.
Hi, my name is Nathan. I run the performance engineering team at StackPath. My background is mostly in scale. I am able to build out these very, very large scale systems, make things work at very, very high volumes. I'm here interested to talk about microservices because one of the things that the StackPath platform brought out just this last year is a containers as a service model. So what we did in order to make this scale was we built out in every single one of our edge pops, we have the capability of bringing up containers which are intended to host microservices. So we can we have built out this globally distributed computing platform. And so I would really like a chance to talk a little bit about how this enables very, very low latency transactions, the necessity of low latency, especially in terms of a microservices reference architecture. And I'm very, very happy to start diving into some of the details about how you can take an existing system and what kind of speed ups can you expect to get in a distributed system versus a single solitary cloud.
Perfect. Olga.
Good afternoon, everybody. My name is Olga Kornienko. I am the co-founder and COO of EZDRM, and I am not a technical person like everybody else in this panel. EZDRM has been founded on an idea that DRM is a service, and as such, it's a microservice given how it's set up. So we've been running in a microservice infrastructure before microservice was actually a keyword and a term. So we've been doing this since 2001, and I would love to talk more about it later on.
Perfect, thank you. So we've been running something like this session for the last 3 or 4 streaming media events. And it used to be called OTT Moves Towards Microservices, which was named after an article I put out in 2017, exploring microservices and its applicability to my least favorite word in our vernacular, OTT, but that's a different story. But the time came with this session to talk about microservices in action. However, before we go straight into that, let's make sure we've all got some common consensus about what microservices are. And I think when I put this next question, you'll see that there are nuances in everyone's perception of what microservices are. So can I ask each of you to just give me a brief definition in your world, in your mind, what do you consider microservices to be? Nermeen.
So for me, microservices was to architecture what was cloud to on-prem systems, what was agile software development was to the waterfall model. It's a way to speed up the development and the deployment of services so that it can really match the pace of which consumers are expecting services to proceed forward. And it took from the cloud the concept of pets and cattle, right? That you cannot treat your services if you want to, you cannot treat your software if you want to go really fast as pets. You need to treat them more like cattle, that you can scale them up, they can come and go. You need to design for failure because it's going to happen. And then if you do that, then you can go really fast.
Interesting. Tanu.
So microservices architecture for me is yet another evolutionary step in the world of distributed systems. That's how I look at it. If we go by the definition of what a microservice is, it's really, it's about creating small services that do one thing and they do that thing really, really well. So they're single purpose, single focused. They do not share the data with anyone. They do not have any dependencies. They're very well self-contained, self-independent. And what that means is that you're able to build them, able to test them, and deploy them with complete independence without disturbing any other part of your product. So what do they really bring? What are the advantages? There's a slew of advantages that microservices bring, but I want to highlight 3 of them. The first of them is the ease of horizontal scaling. If you have a monolith that you're trying to, as a product, that you're trying to scale, now what happens is, if you need to scale it, it needs to scale vertically. If you're able to break that monolith piece of code into smaller pieces of code, each with their own functionality, then you're able to scale only the pieces horizontally that need to be scaled. I'm going to give you an example from a past life where I was working on a cloud recording system. And this was a microservices-based system. And there was a need to increase the number of channels on this cloud recording system. The number of customers or the playback was going to remain constant. So instead of having to scale up by adding more boxes vertically for the entire product, we were able to just scale up the channel manifest reader or any microservices that were per channel. And so here's an example of horizontally scaling out things. So I think that is one big advantage. And then Nermeen touched on the second advantage about agility. Because your developers are working on small products, small things, and they can work on them independently, you're able to get things faster. You're able to make changes much faster, turn around. And lastly, I want to point out another important byproduct of microservices, again referring to the pets and cattle example that Nermeen brought up. How do microservices make our systems more resilient? It's because the architecture paradigm is based on the fact that these microservices are fragile and they can fail anytime. System designers now think about not figuring out how do I prevent failure from happening, but they figure out how do I recover from the failure, which is a lot easier. So now what you're doing as a service, your small service, is deciding, okay, if I have to make these requests outside, and if these requests don't come in time, what is my behavior going to be? How am I going to be gracefully recover?
Perfect. Nathan.
First off, I'm in complete and total agreement with what Tanu just said about that. The only thing I really have to add is I usually define microservices in contrast to a monolith. So all computer programs, all apps, you have an input, it goes away, you have this black box that does something with that input to give you an output. And the whole point of a monolith is everything is hidden behind that black box. But with a microservice, you break out that black box into its different stages of its workflow. You can then encapsulate the state of what each work stage has to do, such that you can pass that around as its own separate thing. And what this allows you to do is exactly open up the world to be able to rip out a work stage, replace it with a completely brand new one without changing any of the rest of that pipeline. So it's a really good way of breaking down the workflow, and it's a really good way of making sure that everything is correctly encapsulated such that you do not accidentally destroy something else. So it's a much more robust way of developing very, very large-scale apps.
Perfect. Olga, have you got you've probably got a nuanced definition because you're application specific. So.
Well, it is kind of very hard to follow these people and try to add on something new to a very, very thorough definition of what a microservice is. But just like Nathan said, I think in my understanding, microservice is it's more in a business function. It has to do one thing, and it has to do it really, really well. And it has to be on that same side agile enough, flexible enough, and lightweight enough to do this thing without slowing everything else down.
Okay, perfect. So question to the audience. Anyone got any questions back after those definitions? Does that make sense? Great. Hold on, I'm going to run up there. Let's get it on the webcast. Hold on, I'm going to run up there.
In these definitions, I didn't hear the keyword stateless. State and stateless, where do they come in?
That's a great opener. Nermeen, I'm going to come to you first.
So traditionally, a microservice, in order to be able to scale horizontally, would need to be stateless. It doesn't mean that there is no state in the system. I mean, you cannot build a system that has no state. It's just that you keep that state shared among the various instances that make the actual service, and you make it shared in a place where the hard job of keeping the state consistent, replicating correctly, and so on, is not in every single microservice, but it's in your database, in your Redis server, wherever you need to keep the state. There are sometimes instances where your application just by definition is stateful. You try to avoid that, but sometimes it's not avoidable. So you'll see that the modern microservice management systems like Kubernetes, for example, started to introduce the notion of a stateful set where you can actually deploy something that also has state. It's a bit harder to do. It has some things that one need to be very careful about when they designing something like that, but you can design it. But in general, if you can make your services stateless and keep the state outside of them, then that is a much, much faster, much, much nicer way of building your service.
Any other comments on state from the panel?
I think it's hard to top that.
So it's interesting, it's just to comment on that, within the Erlang paradigm, we tend to distribute the state across all our functions. So any function can take over as the master node in the event of a net split and so on, but it might be slightly different paradigm. Okay, so some of the delegates here will be looking to take their existing platform from probably a collection of monoliths that are somehow integrated into a microservices environment, into a microservices model. So I'm going to start with you, Nathan, sort of continuing the path along. What would your sort of hot tips be for migrating from a monolithic architecture to a microservices architecture? Nathan.
Oh, thank you. No, it's no worries. I'm very happy to.
No.
But just as brief as possible, the nature, I talked a little bit earlier in my definition about understanding what the workflow was and being able to break your workflow out into those individual stages where each stage is appropriately encapsulated for what you want that particular stage to do. So every stage has an input, has an output, passes that off to the next stage, input, output, and so on down the chain. So you get this sort of chain microservices together in order to get you your final answer that you actually wanted in the first place. So that's the first thing, is you have to understand the problem space well enough that you can break it into its individual components. To continue with the discussion on state, you have to know, ideally, everything is sufficiently discrete that you don't have to pass in any state data across. If you're lucky, if you're unlucky, it comes down to your specific use case. Maybe you have to shoehorn something in to accommodate for that. But once you understand the workflow, then you can break it out, and then you can determine what it is that you want it to do. And then you can start applying the usual failure analysis against this. You can start applying the usual separate and discrete logic that you want that particular one to do.
Perfect. And Olga, presumably you've moved from some sort of monolithic environment into more of a microservices strategy over the EZDRM's lifespan?
Well, actually, we are on the opposite side of moving people from a monolithic environment over to our microservices, mostly because we believe that just like Nathan said, in a monolithic environment, a process does everything, and figuring out a point of failure sometimes is really, really hard. And if the whole system fails, digging through various pieces to see which one actually failed is a process. Whereas if you can catch, just like you said, input and output and see where the process is going and figure out the one piece that is failing is the part that you want to do.
And what were the business drivers for moving to microservices with a DRM service?
Well, I guess with the DRM service, you're looking at somebody who is a specialist in the field. You don't want, taking the non-technical approach to it, you don't want your plumber installing your lock on your door because they're not the person who knows what they're doing. And in a microservices environment, the idea is to find, in any microservice, be it DRM or anything else, the idea is to find the person who knows exactly what they're doing, and just because they can do 12 other things, you don't really want them doing your security as well.
Okay, so I'm going to run this next question right along the panel. In terms of standardization, we talk a lot about containers and so on, but it's kind of a funny term. People think containers are microservices. They're not, in my mind, completely synonymous. But as both vendors and service providers in the sector, At what stage do you think, or are we already at a stage where all the different components that you could plug together to make a live streaming workflow or a video on demand workflow, can you go and buy these as containers off the shelf and just run them? Or are they things that you have to develop at the moment? Or where are we at in that evolution of the industry? Nermeen.
I think there are things that you can get as containers, or the nice thing about, as you said, maybe I'm just going to start with the microservices and containers, what is the relationship? I definitely built a microservice-based system before containers were productizable, right? So it wasn't containers. You run your microservice as a process in a VM. It's just very hard to scale that, to deploy that, and especially when you have multiple environments that you have to deploy in. It's just very, very hard to do that. Containers help you with that. So containers is a way to package your microservice in a way that is repeatable. So whatever you are testing, whatever you are putting in your development environment, in your staging environment, is the same that's in your production. So you know that it's the right thing. So there are definitely services that are packaged as containers that you can get. For most of what we do, we need to differentiate between what is context and what is core in what we are building. So core is where we can add value that you cannot get from just putting things and integrating things together. But we will get whatever we can as long as it's in the context of what we are doing, and then we add the value add to that. And I think that's very important because you can then go much, much faster if you can leverage other things, especially when, as Olga was saying, stuff to do with security. You don't want to be doing it, not only because maybe you're not the expert in that, but because you want to use pieces that are hardened, that you know that it has been tested, it works, and it's ready to go.
Tanu, are you the same mindset? Are you able to buy lots of services from the market and integrate them, or is it still a strong balance in terms of rolling your own?
So my belief is that right now in the industry, we're at a place where you can easily make your containers based on the services that the cloud services, the public cloud services provide. The whole idea of containers and microservices is what is your core competency. We let you focus on your core competency and make your container for whatever it is that the product that you're building and bringing to the market. And you can leave everything else that you need to the cloud providers. So again, it's in a place where I think we can come up, we can create our own core competencies in containers, and yes, we can start selling them as well. You want to, I completely agree with Olga and Nermeen, you want to leave certain things to the experts, and why reinvent the wheel? So I think that's where containers are helping out.
Nathan, any thoughts?
Yeah, I actually wanted to hop in with a little comment here that we used to have this thing called dependency hell. And the idea is that when you go to deploy something, it's potentially different from the development environment, which is potentially different from your staging environment. And you had to keep all these synced in order to be guaranteed that whatever you pushed into production was actually going to do what it was supposed to do, just the way it did in development. The wonderful thing, one of the wonderful things about containers is it gives you a common image. And so therefore you're guaranteed, if I can deploy against my container within development, I'm guaranteed I can deploy against my container in production. And it's all going to work. So this actually solves a lot of what we would call a DevOps problem. And so it's very, very useful to think of it that way. And a container is a container because it contains a microservice, to bring it back into context with what we're really talking about. So the words are chosen for a reason, and they actually do fit together correctly.
Olga, so you're obviously more from the vendor side, you're providing microservices. I'm going to slightly twist the question because I think it's going to be easy for you to answer. So do you have to adhere to certain standards in terms of delivering EZDRM microservices to the, I was going to call it an app market. It's more of it's not even a container, microservices market. Do you have to conform in some way to the frameworks to do that?
Well, I was actually figuring if you weren't going to change the question, I was going to kind of pivot that way. It is a double-edged sword, so to say, because we do have to, on one hand, set up a set of standards like CPICs, the key exchange that is prevalent right now within the DRM and encoding environment, is one of the perfect examples of trying to standardize the world so that it doesn't matter which DRM provider you choose or which encoding company you choose or which other service you choose, they can all talk to one another. I also think it is up to the companies and the people implementing microservices to make sure that we work with our partners so that we can actually provide a service to the client. Because if we don't have clients, at the end of the day, none of this is possible or doable or even has a point. So for us, I think the most important thing to do is figure out a way to make sure that we all work together within this industry, as well as follow a certain set of formats and standards, and maybe even come up with a set of standards that might be counterintuitive, like figuring out a multi-CDN environment or any other multi-provider that competes with one another environment where it makes it comfortable for the client to feel like they're not locked into a vendor, and they are able to switch vendors as well as switch out the microservices from one company to another without massive deployment issues, massive downtime, and whatnot, which, you know, as a microservices provider may be kind of sort of counterintuitive, but at the end of the day, I think the customers will benefit from something like that.
You just killed my next question, which was all about vendor lock-in. So I'm going to go back to the audience. Are there any other key points you'd like me to... I'm going to try and do the Q&A from you guys during the session so you don't all to go into an after-lunch malaise. Any other questions from the audience at this point? Okay, let's keep rolling. So, deciding between a monolith and a microservices architecture, how do you make the decision which is right for you? Is there any case these days for a monolithic architecture? I'm not probably of the opinion anyone at this stage is going to think there is, but...
Well, I mean, if you are building something that's really small, you don't need the huge scale, there is no reason to go with the complication, right? Complexity that you get from a distributed system. But these days, it's very hard to imagine that, you know, a service that's, you know, that way. Mostly we try to get something at scale. Most of the services are quite complex, and they are not simple. But I think if you are moving from a monolith to a microservice, or you are going to create a distributed system, it's very important to understand that it doesn't come cheap. It's hard to do that. All the problems that you used to have with a single component, now you have it with multiple components, right? They don't go away. You have to deploy them, you have to manage them, you have to secure them, you have to make sure that the latency is under control. All these problems are still there, but multiple times. So it's very important to look at what kind of management framework you're going to be deploying along with your distributed systems. How are you monitor for problems and failures when they happen, and so on. So it's typically, I think people would go with a distributed system, but they have to be prepared for it.
I saw Nathan go for his microphone, so Tanu, I'm just going to jump over you.
I was just going to offer, I'm in complete agreement here once again. There are use cases for monoliths. I want that absolutely positively clear, and there are absolutely use cases for doing everything. And it comes down to what is parallelizable versus what is serial. And if your entire problem is strictly serial, there is no parallelization to be had within it, then you're stuck. You have to have a monolith. You can't split it up. Or if you have something, and this goes back to our earlier discussion about state, if you have something where the state is constantly changing and constantly being updated within it, well, you can't pass that around to every single microservice, so it has to be within a monolith. So there are use cases for it, but you have to be very, very careful and think through your problem, understand the use case sufficiently well to know when you are willing to make that compromise versus when you are willing to go with a full-blooded microservices architecture. The specific example being with, HTTP is defined as a stateless protocol, and therefore if you have a problem, if it's so incredibly well suited to a microservices architecture, you can just pass these little objects around. And if you can do that, great, your problem is amenable to microservices. If you cannot do that, you're stuck. You're going to have to be stuck with a monolith.
Tanu, when not to monolith and when not to microservice?
So I'm going to say when to monolith and when not to microservice to wake everyone out of their post-lunch stupor. It seems like a no-brainer that if you're starting something new or starting something small, let's start with the perfect architecture, microservices architecture. Let's break it up and start the right way. However, there's a case to be made for monoliths here. If you're building a new product, if you're bringing something new to the market, if you're doing a proof of concept, for example, you actually will probably need to pivot many times. Your product will go through several iterations. Do you really want to get into the mess of microservices? As Nermeen pointed out, they're complex. There are lots of decisions that you have to make up front when you're using microservices. Perhaps at that time in the life cycle of your product, starting with a monolith is the right thing. You probably have a couple of developers on your team and you're starting the product. Then what do? Do you start with microservices or a monolith? Maybe you don't do both. You go the middle path. You divide it in such a way that you can have parallel development. And this is a little different from what Nathan mentioned about parallelization. This is really about being able to develop in parallel. And a couple of these services can work together. The reason I'm advocating deferring the use of microservices to as late as possible in your game is because you don't want to make that investment up front. You want to focus on your core competencies, get your product out, put some live traffic through it, evaluate it, monitor it, and you'll be surprised that the pieces that you thought needed to get scaled are actually not the ones that end up needed to be scaled. So again, something to watch out for.
Olga, anything on that?
See, I actually think I would not agree 100%. I mean, granted, I'm biased in this kind of opinion, but I also think that you need to figure out what it is your core competency is. I fully agree with that. Figure out which part of it you absolutely need to control, need to be in charge of, and which can be diverted to a microservice. And then decide if it's worth your time to develop, build, and figure all that part out, or if it's just easier to contact the microservice provider, figure out if that is you don't have as much startup costs, you don't have as much of an infrastructure that you have to invest in order to spin up a service that could be purchased or acquired as a microservice, and decide on the few components that you need that you absolutely have to do, will be changing, will be pivoting, and the two things that you need that can be bought off the shelf from a provider out there, and do a combination, I think would be the best way that I think should be approached.
Perfect. Okay, quick breath check from the audience. Any questions? So if you're ready, I'm going to sort of, each time we pass along the panel, I'm going to go for one. There we go. We've got one at the back there. Hold on, I'm just coming. Jog off my lunch.
I was curious if you have a different strategy for data access in a microservice versus a monolithic application design. Like some data access can be very expensive to perform, and you don't want to repeat it for every microservice. So what's a good strategy there?
Right. So I think that's a good example of where you might want to not break up your microservices into really small services. You might think about putting them together to start with so that you can share data. So microservices do talk about the dogmatic definition is you don't want to share any data. But there are situations in real life where as you're developing the product, you don't want to be distracted by making sure that the data is consistent or not across different databases in the microservices. So that's what I was trying to advocate for. When you get started, don't break up into very small pieces, grains of sand. Start with an architecture that mimics your business, that mimics your organizational structure, and then take it from there. When it reaches a point where your product, where the service is not able to handle the data, and now you see, okay, we need to split it up into 2 different databases, that's where you start splitting up your monolithic service into smaller microservices.
Okay, so operationalization. Okay, it's kind of a key challenge, people building service platforms using microservices. What are the key considerations? Obviously, we've got a lot more things potentially that need to be secured. We've got availability issues, and we've got deployment strategies. It's a nice broad sort of topic opener more than a specific question there, but if you were going to be giving some key points of advice to people here who are looking to operationalize with microservices, what would stand out? What would be good strategies? What would be good key things to take into account? Nermeen.
So look around and see what is available. There are unbelievable amount of tools that's available today to help with the operations of a microservice system, from the deployment, scheduling, and lifecycle management of the various containers to how to have a monitoring system for both your nodes as well as your actual containers, to how to secure them both at the network level as well as the service level. Don't do it yourself, and don't start and then figure out what you're going to do. Think about the operations from the start. Figure out what framework would work for you in every single aspect of the operation pipeline, and decide on that. And don't forget your CI/CD pipeline. It's extremely important. Don't build a micro-distributed system without a very solid CI/CD pipeline, because what you will build a complex system and it will slow you down at the end of the day rather than speed you up.
Tanu.
So all good points, Nermeen. So in addition to operationalization, if I can say that, what is the mindset of your team and your engineering team? You have to take a look that, is it a DevOps culture? Are they into being able to develop, make small changes, and then operate the service, take feedback from that service, monitor that service? There's a mindset change that's required there as well. Is your team ready for that? You want to put all the tools in place before that. And as Nermeen mentioned, there's a lot of material out there, so you don't have to start everything from scratch. You can start reading. You can go towards the cloud vendors that provide lots of these services. You want to have your continuous test, continuous integration, continuous deployment cycle in place. You want to figure out your RPC mechanism, how are these microservices going to talk with each other? You want to figure out, are they going to authenticate with each other or not? These are some of the best practices that are available that you need to start following, need to get in place before you decide on breaking up the architecture.
Nathan, any thoughts?
Yeah, I thank you for that, because I really want to take a chance, take the opportunity to plug a group called the Akrino project, which is done by the Linux Foundation. And what these are essentially, they call them playbooks, and it's a very detailed specification of how to go about accomplishing something, where exactly they're encapsulating what's the best practice, how's the best way to go about doing that, and that's the whole point of the playbook. So absolutely, there's a lot of material out there, there's a lot of opportunities out there if you just want to dive in and get started. So I'm going to just real quick shift and end up on the comment about the DevOps culture, because I agree. I think that's incredibly important. The way that we develop and build apps today is very different from what we did 10 years ago. It's wildly different from what we did 20 years ago. And a lot of the modern practices that have arisen from like the extreme programming movement and a couple of other movements, well, that's one of the goals of microservices, ultimately to take care of these previously defined best practice patterns. We used to call them design patterns, and to be able to apply that in a practical manner. The whole goal is to get working code out quickly, and get something that does what it is that you need to accomplish with the least amount of effort on your part.
Olga, thoughts about operationalization with microservices?
I think for me, it's kind of hard to talk on the topic of implementing microservices since we are basically on the other end of it. I think to kind of add on to what Nathan said is, do the research and figure out what microservices you need, and build an infrastructure where it's multiple vendors who are the best at what they do, as opposed to going to one vendor and say, well, they have this service and this service and this service and this service, and I would just stick to one vendor. Do the research and figure out who is the specialist in the field of what they're trying to do and what you need them to do, and know that if there is a very well-designed service, that chances are there's standards that go with those services, that you would be able to swap them out if you needed to, if something didn't work out, without having to rebuild everything from scratch, and take it in that direction.
Okay, perfect. Quick break for question from the floor, anyone? Okay, you missed your chance. Latency. This is obviously, it's a big topic. You can hardly move through anywhere in the streaming sector without the word latency coming up at the moment. It has cut in our sort of warm-up email exchanges planning for this session. It came up from everybody. What are your thoughts about latency in the microservices environment? Does it have impact? Is it important? I'm looking at Nathan because he mentioned it a few times.
Latency, I'm against it.
Okay.
Down with latency. Yeah, obviously I'm employed as a performance person. I'm supposed to go look and see, one of my key metrics is always latency. How am I pushing latency lower? And this is actually one of the really fun things with microservice architectures, is because, again, you identify your stage, you can break it out, and you know what your latencies are going to be in every single work stage of that pipeline. And from there, you can add them all up, and you know what your total latency across it is going to be, which means you now know how many requests you can actually send through. So therefore, you know your throughputs. And you also know from your throughputs, you can then start to calculate how your performance curve is going to look like, because no service goes up monotonically increasing, right? There's always a cap, there's always a knee in the performance curve. There's always a problem where you exceed a certain magic number and all of a sudden the performance starts to go away because you've saturated something in the pipeline. So you start spending a huge amount of time doing bottleneck analysis to try to figure out where's the bottleneck, you alleviate that, run it again, figure out where the new bottleneck is, alleviate that, run it again. So it gives you an actual model, it gives you a way, it gives you a framework of approaching performance, of minimizing those latencies, which you don't really have in a monolithic architecture. And I think this is one of the misunderstood, or maybe not as well appreciated points of a architecture like that. So it gives you a little bit more visibility into what's going on under the hood.
Tanu, latency in Twitch must be a reasonably important element.
It is, and I just wanted to add, Nathan, excellent explanation there about you want to profile your different microservices. You want to actually find out the bottleneck. Yes, if you're going to break up your architecture into small pieces and they're going to talk to each other, you know, inherently there's going to be some latency that will creep in. What will be surprising, though, is that unless you measure it and monitor it, you won't know where it is and what is it that it's going to needs to get improved. The patterns that apply to reducing latency for distributed systems are the patterns you will apply in your microservices architecture as well. These problems don't come in monoliths, but I want to give you an example from Twitch where we have a very critical CRUD API that kinds of monitors all the video edges that we run. And it finds out the network connectivity from the video edge, the Twitch video edge, to the viewer. And now, this is a critical API. We are monitoring this every tens of seconds. And then updating it back into a mapping system which decides when a viewer wants to watch a live broadcast, how do we get the master manifest to that specific edge, and how do we move the user to that specific edge. This used to be part of a monolith. Not recently, a few years ago, we pulled it out of the monolith. The interesting thing is that the API has a P90 of 100 milliseconds, whereas the information that's coming in is at the order of tens of seconds. So how do we settle this discrepancy? It's a simple pattern for distributed systems. You cache the data. So the mapping service now caches the data when it needs to find out the network. And in the background, it keeps updating that data from the network. So it knows which is the video edge that the viewer should go to for best quality of service. So again, there is a way to solve these. There is a way to apply these patterns into your architecture.
Nermeen or Olga, any more thoughts on latency?
Yeah, I mean, distributed systems have a bad name for high latency, but I think it's badly designed distributed systems would provide lots of latencies. I think if you know from the start what kind of latency budget is important for you, you can design the systems to be within this budget. And again, as everyone said, you need to measure. There are lots of APM software there that would help you with your performance management and then solve the bottleneck. But that's just one part of the piece of latency, which is how the latency because of microservices talk to each other in order to perform a specific function. There is also the containers, because no one is going to today, I would assume, do a microservice system without using containers. The container networking itself also has a bad name for introducing latency within the node itself. But I think that that's not really true, because virtualization does provide lots of latency. But if you put containers on top of bare metal, then you have exactly the same latency that you would get if you just deploy without a containerized system. But you need to optimize exactly as if you have optimized if let's say you're running on a Linux system, right? So you need to make sure that your containers are scheduled at the right time, they're not starving, nothing else is starving them on the same node, and so on. So I don't think that microservices add to that, despite the fact that typically people would think that they do add to that latency.
Excellent. Olga, any last comments on latency there?
Well, as a provider,
Yeah.
latency is obviously a huge, huge issue, knowing full well that we will be going in line with all other microservices and possibly adding on. One of the things that we've figured out is if you can start a microservice or start a process and then kick off another process to go alongside of it, that basically cuts the latency or staggers the latency. And also, having worked with our clients to see where they're at, help us test, help them test to make sure that what we're seeing and what they're seeing and how we can cut down the time from point A to point Z.
I should imagine you sometimes get into an interesting situation where it's not very clear whether it's your microservice or whether it's the infrastructure or the operator's choice of where they deploy your microservice, which is introducing the latency. So I presume you have to do lots of benchmarking and testing with the client to evaluate that sort of stuff in advance.
There's a lot of benchmarking, there's a lot of testing, and there's also a lot of just sitting down with a client and or with a partner and figuring and just watching the process go and figuring out what can be done to cut on this and help that and speed that up.
Cool. I'm staring through this sort of strong lights to see if Bill's waving me off stage, and he's not quite yet. So let's see if there's a question from the floor. If you guys are wake up, if you guys have come to after lunch, if there's any last question from the floor, we'll run one through the panel. In which case, I'd like to say a big round of applause, or I'd like to go a big round of applause for an excellent panel.